Hello guys, this is question 5.25 of chapter 5, and the statement of this question is: suppose that for a very large shipment of integrated circuit chips, the probability of failure for any one chip is 0.10. Okay, so let me write the given data here. So given data, let me write it with this blue color. The probability of failure is what? This is given, and this is 0.10, assuming that the assumptions underlying the binomial distributions are met. It is already given that we are going to use the binomial distribution. Find the probability that at most 3 chips fail in a random sample of 20. Okay, so the random samples or the total number of items here are 20, and we want to find out the probability that the number of failure are at most 3 chips, means failures are less than or equal to 3. We have to find it out. Okay, so let me solve them here, and in order to solve them here we have to use what? Let me use the formula for it, and the solution of it is here. I want to find out the probability of failure which is less than or equal to 3. Okay, so in order to find it out, this is what? This is all the items which basically lies in this range are the probability that we have 0 failures plus the probability that we have only 1 failure plus the probability that we have 2 failures and plus the probability that we have the number of failures equal to 3, because at most we must have 3 failures. So the formula for it we are going to use is, let me have here the probability that the number of failures are k. This is what? This would be n choose k, and the probability of success is k, and failure is n minus k. Okay, so here this p is p of f, this small n is this capital N, and this k, this is here all the items here. So for each of the item here we have to apply this formula. Okay, for each one of them, for this and for this as well. So therefore, in order to find out the probability that f is less than or equal to 3, we have to apply the similar formula for k is equal to 0, up to 3, and here we will have to apply and choose k. Okay, p of f will remain the same, raised to the power k, and here we will have 1 minus p and minus k. So 1 minus p of f, okay, and minus k. So applying it here, what would I get? I will have here n choose 0. Okay, and here it would become 1, because this is 0 and 1, and here we will have 1 minus 0.10, so we will have here 0.9 raised to the power n minus 0. So n minus 0 would be n. Okay, plus for the second item we will have n choose 1, p of f is 0.1, so 0.1 raised to power 1, and 0.9 raised to the power what? This would be n minus 1. Okay, plus n choose 2, 0.1 raised to power 2, and 0.9 n minus 2, plus here n choose 3, 0.1 raised to power 3, and 0.9 n minus 3. Okay, for all of them we have n equal to capital N, which is 20. Okay, you have to put all these values here. So let me move down somehow. So here ultimately we will get what? We will have here 20 choose 0 and here 0.9, okay, and here 20 plus 20 choose 1, 0.1 multiplied by 0.919 plus 20 choose 2, 0.1 square and 0.91 plus 20 choose 3, 0.1 cube and 0.9. 3 minus 3 would be what? This would be 0. So rate will be 1. Okay. So finding them all here, so it would become 20 factorial divided by 20 minus 0, because you can see here that A choose B is always equal to the A factorial divided by B factorial and A minus B whole factorial, applying them all here. So ultimately from all of them together you will get what? Here you will get the probability that the failures are less than or equal to 3. So you will have the amount, let me call it x, and that would be the answer of our question. So I have told you how to apply the concepts here, how to get the answer, and whatever we have here would be the answer we have. Okay, so that's basically the solution of the question 5.25. If you have any question, if you have any ambiguity regarding the question, you can ask me in the comment box. See you soon.